So welcome, I'm Eric Veal, and tonight we are here for another Space Data Hackers. Today is August 28th, 2024. So summertime, end of summer, coming up on Labor Day. And I'm your host tonight. So tonight we have Alistair or Al from AWS with us, and the topic tonight is Amazon Web Services and their space department. What are they doing there? How does it relate to AI and ML? And Al and I have had a chat previously and got to know each other a little bit. And so I think we're going to have a fun discussion tonight about technology and space and what does it mean and how does it work. And so pretty excited about tonight's talk. And Al's really, I would call him kind of our subject matter expert, but kind of the purpose of tonight's event, as I would think of it, Al, is just kind of an open discussion about what is it? What is almost like what is space or new space, and how is the cloud involved, and how is big tech involved, and what does this industry need, and a bunch of stuff. So I think this is going to be a great talk, great event. So thanks to everybody that came. So I'm Eric Veal on the right here. AppShack is my thing. I've been in big tech for a long time, and have been doing my own thing for the last year. I'm saying tech done wisely here, but we're really mostly focused on human resources, kind of innovation, especially using Gen AI and just like advanced tools for doing HR better and making better experiences for employees and other people. And as an employee for 22 years, I'm pretty passionate about that because it wasn't always good. So trying to re-engineer and reinvent that. And then Mike Doyle is really kind of the founder and architect of all this, Space Northwest and Space Data Hackers, and the true visionary of like this group and the real kind of brains behind the whole operation here. And Space Northwest, of which Space Data Hackers is a subpart or just kind of a program within it, but Space Northwest is a broader collection where it's connecting humanity's future in space, but a lot about career and other things. Space Data Hackers community just kind of get together on a monthly basis, meet somebody that's working in the new space industry, ask them some questions, and try to network a little and kind of figure out what's here, how it relates to our world. Tonight's agenda, just like this is the welcome section. Like this is just me saying hi and welcome and kind of explaining how things work. And we'll tee up Alistair in a little bit here. Then it's to his presentation. And like I said, tonight especially, like sometimes people kind of want to stand and deliver their particular speech or whatever. Alistair, I think, has a few slides, but it's mostly dialogical and conversational. So kind of be thinking of what are your most basic questions about space and new space in this business industry, and how does it again relate to big tech, and who knows, West Coast, Seattle, like what are people thinking and what are the opportunities here, that kind of stuff. Space Data Hackers, again, like there's our meetup site. It's probably why you guys are here tonight, is you had to sign up through the meetup site. So make sure you pay attention to that. Space Northwest, if you wanted to become a member, here's how. Just spacenorthwest.org, whack membership. So you can inquire there. Space Northwest, they want just help. It's a volunteer org. So if you kind of want to get involved and meet people within the new space ecosystem, if you will, and just like whatever, network and show off your talents and try to weasel your way into a job or a new career, whatever, this would be one technique. So info@spacenorthwest.org, and definitely feel free to ping people on the side or whatever here on the Zoom, just say hi, and feel free to drop your LinkedIn connection or other contact info into the Zoom while we're going here, just to network around a little bit and all that. We're not really set for the rest of the year in terms of topics. So this is another thing, like maybe after Alistair's done, we can brainstorm for 2 minutes on what we'd like to see or who we'd like to hear from next. If there's some thread we'd like to keep pulling, who else we could pull into this discussion about just new space and innovation and what we want to learn about, etc. So that's kind of the purpose, and it's open. My email is Eric, ERIC @appsjack.com, but you also have the info@space if you wanted to do that either way. So here's Alistair. Again, I met Al. He goes by Al. I don't know if I know if I say Alistair or Alistair yet, so he'll probably straighten that out for us. He's principal technical BD. Is this business development?
Yeah, that's right.
Okay.
It's a bit of a
Developer,
mouthful.
developer. So he's a bit of a sales guy, so let's not judge him too harshly. And he's in AWS. And so, I think the hypothesis here, or the truth is that AWS, not only does it support whatever payload, it also supporting things related to new space and space data and businesses that are doing that. And AWS is behind that. So that's super cool. I won't drain this. Like, Al, is there anything you want to say about your background or what's kind of written into it? You want to tell us a quick potted of like what brought you here today?
Yeah, just been at AWS for 8 years now. I was a solution architect, so very heavy tech for most of those years actually, and only recently become a BD person, so moved over more to the kind of the sales side. So we can go as deep technically as you like, and if I don't know the answer to stuff, I'll just tap out. Yeah, been at Amazon for 8 years, been in space for 3 years now, and been very active in AWS during that time. Done lots of talks at reInvent. Done reMars when they did that in Vegas, if anyone remembers that. And I've spoken at various space industry events over the past couple of years. Really, really, really passionate about space. Really passionate about connecting space to all different industries and how we can sort of move forward and nothing less than the future of humanity. Originally from Scotland, so you probably detect a little bit of an accent, but now I live in Connecticut with my two girls, and yeah, that's really me.
Very cool. Welcome. So I'm just reading the second paragraph here. So it seems like it's possible to go from banking to new space.
Well, it was banking to AWS, and then AWS. I was actually in the state and local government education team for 5 of those years, and then joined the space team after that. But I'll get into a little bit about what skill sets you need for that team and how that came about and all of those kinds of things.
One joke question: why not put everything on premises?
Well, lots of reasons. Lots of reasons. Yeah, lots of reasons. Resiliency is number one.
Why can't we just do this all in-house? Why can't I build that team?
Cool. As I say, listen, I'm not here to give you a lecture. I'm here to have a conversation. I'm super interested to speak to people that are interested in space, whether you have, literally gone out and looked at the night sky for the first time, or you're very deeply embedded in the industry. Always really happy to speak to people, really happy to speak to people about AWS. This is absolutely not going to be a sales pitch. This is going to be, a conversation between you and I, just about things that you're interested in, right? And I'll talk about some things that we're doing. I'll talk about some use cases at the intersection of space and AI that I see in the industry today, but very happy to field questions. If I can't see the chat, so if someone would be very kind and just shout out if there's stuff in the chat. Otherwise, feel free to just sort of come on camera and ask questions. And we'll just go from there. So yeah, as mentioned, my name's Alistair McLean, originally from Scotland, based in Fairfield now, so it's a little bit late my time, but that's okay. I don't mind. I got permission to stay up late. And we're just going to go through what this aerospace and satellite team does at AWS, why we kind of got made, what we do, the customers we work with, and then we'll kind of back into a little bit about machine learning and AI. So I've been a machine learning and AI person for probably about 15 years at this stage. I did a lot at Morgan Stanley. Prior to coming to AWS, I've done a lot since. I've seen, growth from, relatively straightforward machine learning practices using XGBoost and some of these more tabular algorithms to today's all singing, all dancing transformer models with their billions of parameters, et cetera, et cetera. So I think I've got a really good grasp of the AI industry in general. But I've also been extremely lucky for the past 3 years to be working in space, primarily in the satellite industry, although now I sort of cover the launch and the ground segments and stuff as well. So yeah, really happy to be here, and thank you so much for giving me your time today. So I guess if we start just to say what my team does. So we have the aerospace and satellite team at AWS. It's a global team, okay, and it's comprised of salespeople, technical people, BD people, marketing people. There's quite a large number of people behind the team at AWS, and our sort of sweet spot that we have as a value prop is really bringing our cloud expertise as cloud practitioners at various levels, space expertise again at various levels. Lots of people in the team have very wide-ranging space backgrounds, and then we try and combine those into the aerospace and satellite team. And we do that because we like to talk to our customers in the space language, right? We find that our customers are usually incredibly technical. They're very focused, very mission focused, and they really respect and it's our opportunity to earn trust by speaking to them in the same language. So if we can introduce them to cloud concepts that they may not be familiar with, while speaking the sort of the jargon and the language of space, all the better, right? And that's really where we see our kind of superpower as a team. And as I say, we're a global team, so we interact with space companies and space agencies all across the world, right? So I've traveled to some strange places like the Arctic Circle, Dubai, given talks all across the United States. Many of my colleagues, travel to India or Australia or the Far East, talking to people about space. So we're a truly global team. And we firmly believe that space is for everyone, right? I think everyone should have access to space in some way, shape, or form, whether that's for communication or for data. I think space is really, to coin a phrase, it's the final frontier, but it really does light people's imagination on fire, right? Sometimes I have to talk to customers about an S3 bucket or, putting images in a storage bucket, but you have to do it for space things, and it makes it just infinitely cooler, right? And it really helps you sort of get out of bed in the morning and really want to engage with people and get excited about it. And our mission is really to help customers reimagine, right, their space missions and how they design, how they launch things, how they operate, and how they do space, because many of our customers are very new to the cloud. They're very new to cloud computing concepts and fundamentals, and it's incumbent on us to sort of perform that translation and really help them have the best experience they can on the platform, and to be able to really move the needle for their mission parameters, whether that's scaling, whether that's access to hardware that they don't necessarily have access to, whether that's cost reduction, whether that's resiliency. There's lots and lots of different ways that we can help customers reimagine their missions. So we're in a new space age. We really are. We have, the vast majority of satellites in space today are actually probably Starlink satellites. And Starlink has been a real revelation as a product. And it's spurned on lots of other companies to do the same, and Amazon Kuiper included. And we project that there'll be tens of thousands of satellites in space by 2030. And 2030 is really not far away, right? Space tends to have very long cycles, especially for development, especially for sales, etc. So we're now in 2024. It's only 6 years. That's nothing, right? That's very, very close. And we expect the number of objects and satellites in space to grow by an enormous amount. we're in a kind of a new era for space missions. Traditionally, space has been sort of the forte of nation states. Okay, yeah, the United States, China, etc. But now you're seeing a lot more commercial involvement in space, and really the beginnings of a burgeoning and new space economy, right? And that's really been driven by access to space, cost of access, frequency of access. Things like the SpaceX transporter missions, right, have been an incredible success by any measure. By any measure. I think I saw that they had unfortunately, they had a booster failure, but that booster had performed 23 launches into space. I mean, if you can imagine, the mileage on that single booster to perform 23 low orbit and probably higher missions as well over its lifetime, the ROI on that alone is incredible. I think they've been an incredibly successful company, and they paved the way for other companies as well, right? ULA and Rocket Lab and lots of other companies to really sort of pave the way for launch. And I think once you can get things into space more easily, it becomes very, very interesting to perform new things in space, right? And we're seeing customers do everything from, obviously taking pictures, recording data, but we're seeing things like pharmaceutical manufacturer, right? We're seeing compute in space. We're seeing AI in space. Space is kind of the ultimate edge, right? It's the ultimate constrained environment. And we're seeing customers really innovate and push the boundaries of what's possible to perform things in that environment. Let's talk about data, right? This is Space Data Hackers. There is an enormous amount of satellite data that streams down to the Earth every day.
I wanted to pause you on a comment. This is Eric. Sorry.
Sure.
I was disconnecting with what you were saying there as far as you and I had this conversation previously, but like the ultimate constrained environment.
Yeah.
I'm just interested in that topic, and we don't need to drain it now or anything, but I've worked a lot of my career in devices like hardware systems and whatnot, like medical ultrasound machines, and then most recently in Microsoft Surface business.
Mm-hmm.
But like the edge, kind of to your point, right, is like that's a huge topic. And like what does that even mean? A last mile and this and that. But I just want to like maybe we'll flag that for later as far as like what do we mean by the edge, and like how would you model constraints? And I know about some technology that knows about some of that. There's something from Microsoft called I think it's called Olive Tool Chain. I'll paste it into the link, but it's like a way to know what's on the client and like how to make decisions between like what you do on the client and what you do on the cloud.
Yeah.
On constraints, but I'll paste that in. But anyway, fascinating. Proceed.
Thanks so much.
Yeah.
So yeah, that's a great point. I mean, it really is the ultimate, constrained environment. It's difficult. Space is hard, right? It's hard for everyone, and it's hard for robots to function in there. And I would sort of classify most satellites these days as being sort of very advanced robots in many cases. It's hard for electronics to function in space. It's hard for data to be delivered down to space. It's hard for things to get access to power. It's hard to get things access to maintenance. It's very hard to control things once they're sort of in orbit. Everything about space is difficult, but I think that's the absolute reason to do it. I think it's a challenge. I think it challenges us on many different levels, and I think that alone is absolutely worth worth putting things into space, putting people into space, putting hardware into space. And I truly believe that humanity's future is in space. It has to be. I think we need to be able to look back, to give us that perspective, because I think it improves life on Earth fundamentally. And as I say, space is really hard, right? You don't really think about when you're designing a bit of hardware, you don't have to think, well, how does this work in a high radiation environment? or how does this work in a vacuum of space, or what's the thermal characteristics of this hard drive? Because if I don't let it dissipate heat properly, it's going to cook itself, right? So how do you think through all of that and model all of that? It's not just build something, that's hard enough. It's build it in this environment that is completely alien, that we just haven't sort of evolved in, right? And we haven't really gotten used to. I think it's an amazing accomplishment to put anything into space, whether that's a satellite, a person, a robot. It really is a truly incredible thing. But the amount of data that we get, so to this third point, the amount of data that we get back from space is increasing. It's vastly increasing. When I first joined the team, I was sort of thinking, oh yeah, like satellite phones and satellites and things like that. You'll get like kilobits per second. No. Modern satellites are capable of multi-gigabit, multi-tens of gigabit downlinks per second, right? Using different bands, using different RF spectrum bands. And then in the future, in the near future, there's experiments now with optical to ground, right? So you actually be able to get lasers directly from your spacecraft or your space station directly back down to ground, and be able to have fiber optics in space. There's companies that are building connected satellites with optical lasers, right? To be able to talk between the satellites to intelligently route data around them. So I think data, you can't mention space without data these days, because it is an absolutely data-rich environment. There's so much stuff that you can garner from that. But data is easy. I can walk down the street with my iPhone and I'll create lots of data, right? I'll film a 4K, video, and that'll just fill up my iPhone's memory. I think the key is in extracting information, right? And I think
Those could go to 8K.
what fantastic, even better. I've maybe got an older iPhone. That's maybe why I said 4K. But if the 15 does 8K or the 16 is coming out soon, that'd be great. But again, extracting information, I think, is key. So like you can take lots of pictures of the Earth, but what do you do with cloud cover, right? What do you do if there's clouds over the place you want to take a picture? Well, there's satellites now that can do different types of pictures. They can use radar. They can use hyperspectral, right? They can do all kinds of stuff. We'll get into a little bit about how Gen AI is doing that. But I have customers all over the world now wanting to get information from the edge, from the space edge, if you like, back down to ground in the most efficient way possible, and then process that in the cloud. And because the cloud's a great place to process this data, right? It's horizontally scalable. It's got access to the latest and greatest hardware. It's got lots and lots of storage. It grows elastically. All of these things are great. Security as well is, of course, a massive concern, especially if you then venture into the DoD and national security worlds. There's very strict compliance and security requirements there. So being able to process space data securely at scale is really one of the main value props for using the cloud. And that's why a lot of our customers want to do that. And a lot of, more traditional satellite companies that have been around much longer than the cloud, for example, are now very interested in seeing what efficiencies they can gain by even running things like satellite modems and things that are traditionally very hardware based, but actually running those as software in the cloud now. I did a talk last reInvent on building FPGA satellite modems in the cloud, and we've got customers doing that today. So it's a super exciting time to do lots of things. So yeah, thanks, Tim. The hyperspectral imaging, that's a really cool technique that can use different bands of the electromagnetic spectrum as inputs, right? So you would fly a satellite up, and we all see in a very narrow band of the electromagnetic spectrum, which is traditionally called electro-optical. Electro-optical sensors will take pictures of visible light. But some new customers have got hyperspectral cameras, so they can take pictures in, infrared or ultraviolet or other things that are of interest, because different chemicals give off different signatures in those frequencies. So you could point a hyperspectral camera at a field and see exactly how stressed the plants are, because plants give off different thermal characteristics when they get stressed. So you can actually then tie that to an AI and machine learning model to actually calculate yield or health of the person's farm or an area of the world. It's incredibly interesting being able to do all of that stuff. So it's not just pictures, it's all kinds of electromagnetic emissions.
Now, one thing that you and I talked about in our first chat was I worked with Tableau for a long time, and I've mostly worked with business data all my career, tabular data, spreadsheets and databases, relational databases and everything. And like
Mhm.
image data for me feels like the deep end of it. And we've had many people on the past of kind of sensor tech from space. Like last month was I can't even remember the name of the technology, but anybody, June, do you recall? Sorry to put you on the spot.
That was Umbra. That was synthetic aperture radar.
Yeah.
Oh, SAR, wonderful, yeah.
And so it's just like for any given signal, and this is about instrumentation and telemetry, like send it all back. Like we're going to capture it in the cloud or in a database or this and that, and then you can process it. Like is the hard problem on the side of capturing it, i.e. space? I mean, it would seem to be true. And then our terrestrial problems of processing data would seem to be basic, but actually instrumenting space and controlling like what we're trying to do up there and what we're trying to capture, that seems like the hard problem, not
Yeah.
analyzing local data.
Yeah, I think I would agree. I mean, I think in space the capture part is very hard. It's an optimization problem. Now, here's another vocabulary. A piece of vocabulary, if you don't know, it's SWAP. Okay, so it's size, weight, and power, and cost. SWAPC, right? You must build any space vehicle within the constraints of your SWAP budget. So you must be able to say, I have a size, and they're typically done in they're like server sizes. They're like 1U, 2U, 6U, whatever. And within that bus, okay, I'm getting really jargon rich now. Within that bus, you have to fit all of your hardware, right? You have to fit all your sensors and you have to do all the things. And all these decisions are made like a couple of years out from launch. So the hardware that you're going to put in is already like 2 years old by the time it is in space. So you have to think about that. And that's pretty generous actually, right? If you can do the 2 year thing, it's maybe longer, depending on what you want to do. So you have to think, okay, well, skate to where the puck is going here, right? You have to sort of think, well, I want to do this in 2 years, and this is where the hardware is, so I'm going to put this hardware in, and it's going to support my mission. Once you have designed that, you have to find a way to power it, right? So that's usually solar power. Now, solar power in space is really cool because it's actually more efficient than on Earth for obvious reasons, right? You don't have the atmosphere in the way, but it's still a constrained power environment. So you don't have access to infinite power. And then you only get the ability to have power when, those solar panels are facing the sun. So if your satellite is orbiting in a low Earth orbit, and low Earth orbit's defined probably as anything below 1,000 kilometers in height, in altitude. Anything lower than that, you're going to constantly move. Okay, so your spacecraft is going to constantly move. When you get higher out to geosynchronous orbit, those satellites are stationary. They're stationary over a part of the Earth. They orbit with the Earth at the same rate. Okay, but as you come closer, you actually orbit much faster, right? Until you get right down to what we call VLEO, which is like 300 kilometers ish. And VLEO is incredibly quick. And what that means in real terms is that for a low Earth orbiting satellite, I can look at the horizon and I can see my satellite come up over the horizon, up over my head, right? And then down and back and down the other side of the horizon. And that process takes around about 8 to 12 minutes. Now, if you think about how quickly they are moving, they're moving around about 17,000 miles an hour, okay? It's incredibly quick. all of the data that that satellite holds and has recorded must get sent down to Earth within that 8-minute window. Right. So like you have to think, okay, well, these guys have got really, the data rates are high, like for an X-band antenna, you're looking at a couple of gigabits per second. For a Ka band antenna, you can be upwards of 40 gigabits per second in some modes. And it's really incredible the amount of data that you can push down and that you can communicate with the satellite. But the satellite only has a certain amount of data that it can hold. And until it has to, take new pictures or do new sensing things. So it has to make a really intelligent decision about, okay, well, I've got this amount of storage, this amount of power, this amount of bandwidth, this amount of contact time, solve for all 4 of those variables simultaneously, right? And then now you're thinking, okay, well, that's just one satellite. Imagine you've got lots of them. And now you have a real computational puzzle on your hands. It's fascinating how it all kind of works and hangs together. There's actually been attempts. There's a couple of papers about using quantum computers to actually do the solving for these equations, right? Because they think it's an optimization problem like the traveling salesperson problem, right? Trying to route the most efficient way to do the size, weight, and power calculations based on how they fly. Sorry, I'm kind of getting a little bit off track here.
That's helpful. That's helpful.
If I get too deep, then please pull me out.
No, don't be ashamed of that. I think like you and I spoke about this before, is like,
yeah.
I see space as kind of this Internet of Things problem of just stuff moving around up there, and infrastructure and planets and physical objects moving or not. And it's like that's the IoT problem. And I would imagine that everything has a name and an address and a location and that kind of GPS stuff, like more or less already. But then now there's materials up there, have been for many decades, that are smart, or again, sensor tech, and have storage and have additional capabilities that do this, that, and the other thing. And then how does that all work as an efficient and effective network for business outcomes? Like, you tell me. I don't know.
Yeah, it's a tricky problem, honestly, and the companies that can solve that latency from taking a picture from somewhere that's of interest to downloading it in the most quick time possible, if you can crunch all those numbers and solve that optimization problem, then your data is available first. So that's why it's super important to get all of this stuff right and to plan. And it just makes space hard. Space is hard. But that's okay. We know it's hard. That's why we do it, because it's fascinating.
Is it fair to just ground it as an IoT problem, though? Is that oversimplified? Is calling it IoT?
I mean, it's a little bit more than that. I would say it's more in the space of, like, the IoT problem is definitely, and by IoT, I'm assuming you mean sort of network connected, devices that are at the edge. It's definitely all of that problem, but it's more, I would say, because you have all of these other constraints around launch times, around hardware, around how long the thing is going to last in orbit, right? Because if it's in low Earth orbit, it's not going to stay up there forever. It will naturally come back down. And it had these, so they do have lifetimes on them. And you can do certain tricks to extend those lifetimes, but eventually they'll burn up and come back down to Earth. So it's this temporal spatial problem that you get, being able to sort of think about all of the things in space all functioning over a function of time. It gets really, 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 really complicated, but it's we're trying to make it a little easier with cloud tech.
It doesn't intimidate me at all.
That's awesome.
No, I'm kidding. There's some dialogue here in the chat. The question from Tim is, are batteries less performant in space due to temperature? And then Resrick responds and says temp and resistance are equal or related. Temp and power. Anyway, can you comment on the relationship between temperature and battery performance and whatnot? Like, what's happening there?
Yeah, so I mean, I don't design spacecraft. I'm not an expert in this field whatsoever, just to underline that. But batteries are very temperature sensitive, as we know. If anyone has an electric vehicle, for example, they'll get different range depending on the time of year, right? And the same is true in space, but space is a really interesting environment because it has no convection. Okay, so the ability to dissipate heat is limited to certain modes. One of those modes is radiation. Okay, so you need to have ability to get rid of a lot of heat. Actually, heat becomes a big problem in space because the sun can warm things up, and then all of a sudden it'll flip out of the sun's view, and then it'll get very, very, very cold. I think the James Webb Telescope on one side is very, very much hotter than the actual sensor, and the sensors must be cooled, down to sort of, single digit Kelvin or multi-digit Kelvin numbers. It's very cold, whatever it is. But on the other side, you've got the sun hitting it, and that'll heat up, and it's got nowhere to go. It's not like, you can just sort of convect away all of the heat like you can if you pull something out of the oven. It'll just eventually cool down. Heat loss through radiation is actually very difficult, and it's slower. So all of these things have to be taken into account. AWS actually put one of their snowball devices. So we had these small computational devices. We put it up to the ISS like a couple of years ago, and we did it with a launch partner, and that had to go through extremely stringent thermal testing because they were worried that, like, okay, well, it's got certain battery type on it, and how does that perform in different thermal environments, and how do these things work? But eventually we got NASA to clear it, and it went up into ISS. There's lots of blog posts about that as well. And what they did with that was some machine learning at the edge, which was really cool. And that was an example of compute in space. So when you're talking about thermal dissipation, when you're talking about batteries, again, it goes back to, this is a real hostile environment for pretty much anything, right? Things don't cool down the same as they do on Earth, right? You have to test them in this extreme environment. So being able to do that and being able to reason about those is incredibly important. I can't comment on the efficiency of the batteries versus down on Earth, but it's certainly something that the engineers will take into account.
So like design for experiments and like replicating what it's like to be in space when you're on Earth to test.
Oh yeah,
is like clearly a thing. And
yeah,
I mean, is it even possible? Like, can you achieve, like, I think maybe you and I spoke a little bit about like a group that you were working with that does, like, I think you were saying pharma, that in like without gravity or whatever, or, like low gravity, they're able to do something that they can't on Earth.
Yeah, space pharmaceuticals is a thing. So if you can grow crystals in zero gravity, they grow with higher purity than they do on Earth in some cases. And there's companies that have plans to actually do the manufacture of pharmaceuticals in low Earth orbit and then bring them back down. And because they get the higher level of efficiency, they'll actually that's their business model. It's really cool. But being able to, simulate microgravity environments, we can do that on Earth. To simulate high vacuum, we can do that on Earth. Simulate very, very cold temperatures, we can do that. But it all has to be done, right? And it all has to be done for pretty much every bit of hardware that goes into space.
Makes sense. Where are you at in your talk here, Al? You done?
Yeah.
Like, what do you want at this point?
So let's talk about, so generative AI is the sort of the new hotness, right? Everybody's sort of talking about this, and I wanted to talk about how this intersects with space. And what we're seeing is three things. So we're seeing this massive proliferation of data, all right? We're seeing the scalability and availability of compute capacity on the ground. So with GPUs and FPGAs, etc. And then we've seen since 2017 this massive innovation in, go back to 2012 actually, or beyond, but 2017 was when we saw the first transformers being built, right? The paper got released, All you need is attention. It's a great paper. If you haven't read it, go and read it. And that really talked about the blueprint for now what we call Gen AI, right? And all of these different models and virtual assistants and all these kinds of things really grew out of that one paper. It's incredible, and that's very pertinent to space, right? And with Gen AI, you can build these foundational models. And you can pre-train them on huge amounts of unstructured data, right? Common Crawl database, for example, is one that's used a lot, and synthetic data as well, and Twitter conversations and Reddit and all these other things. But what they do is they just sort of throw this vast unlabeled data and tell the model how to split things into tokens, and then just really leave it. And it takes a long time to train these vast models, and what the models are doing is working out token relationships as they train, and that requires an enormous amount of computational power. Some of the cluster sizes, you can Google them, that Facebook and others use that they've made public are just absolutely huge. There are very many thousands of GPUs running for months sometimes, but you get this model at the end of it that you can apply to a lot of different contexts and use cases. And of course, I would be remiss in saying that AWS has Bedrock, which is our service for Gen AI, and makes lots of different models available at the click of a button. It's really, really good service, and we sort of have the latest and greatest all on there. This is kind of the main difference between traditional ML models and foundational models. And what you'll see here really is it's all about the data, right? So it's all about that unlabeled data. So how does this relate to space? Well, we do a lot of things with space customers and Gen AI today. And they are using it from everything from geospatial and remote sensing. Okay, so we can enhance satellite imagery. We can ask questions in text of satellite images. We can sort through vast image repositories using natural language inputs and stuff now, just by utilizing some of these models. And we've got customers doing this today. We can also generate synthetic data using some of these models. So for example, if you're training a computer vision model that looks at parking lots, right? Or pictures of parking lots to count cars or something like that, you can actually ask Gen AI to generate test data for you. And there's a lot of papers saying that synthetic data augmentation actually leads to better model quality overall. I can go through sort of a lot of these. I don't want to just sit there and read them all off to you, but you can imagine that for geospatial and remote sensing, especially when it comes to imagery and thinking about how you get that satellite data down into the cloud, then you process it, how you then manipulate it all within your cloud environment, and making sure that all the constraints around security are taken care of, and scalability and availability. You can get really interesting insights from that very, very quickly. Certainly in like flight and exploration as well. So it's not just from satellites, right? So it's things like mission planning, right? So optimizing flight paths and analyzing constraint systems. Operator training. So I mean, this isn't really talked about too much, but it's a real thing. And it's, if you've got all these old training manuals that you need to train people up on rapidly, or you create like an intelligent question and answer system trained on that data or fine-tuned on that data, it's really valuable to your business, right? And being able to have that whole document corpus accessible as a kind of a virtual lab assistant. Some of my customers are building those, and it's been amazingly transformative to see exactly how that works. These, very dry, very sort of, technical documents, and then being able to query them in natural language and not just get semantic search results back or pattern matching results back, but get actual explanations back, is fascinating. Now, with all of these kind of, models, there is a tendency, or there's the possibility that they can what's called hallucinate. And if anyone's familiar with that term, it means that some of the results that come back have been created in the model or not necessarily in the training corpus. That's tunable, and Amazon specifically are actually doing a lot of research into how to reduce that. But I think everyone that's interested in building these models wants to reduce hallucinations, especially for sort of question and answer tasks. But in some cases, the hallucinations or the creativity, if you like, is incredibly useful, right? So if you're doing language translation, so for example, if you have an old mission control system that's written in COBOL, right, back in the 70s or whatever, and you want to translate that into Java, right? Code translation and code explanation requires creativity in the model to enable that. So in some cases, that's a really good thing to have, because then you can actually run an automated suite of tests against this new code, and then you can see, yes, okay, it's correct or not correct or whatever. But sometimes it surprises you, right? So like for coding assistance, it's generative AI is invaluable, and we can do that now with your own code, or you can use these models as coding help. So like reducing technical debt and technical burden, I think, is a massive application for generative AI that's ready to go now, and people can use it now. Eric, you and I talked about how cool it would be if we had a Gen AI virtual assistant in our spacesuit, right? As we're mineral prospecting on Mars, that these types of things aren't in the realms of sci-fi anymore. These are absolutely things that people could build, right? Okay, we need to get to Mars first. Fine, that's hard. But being able to have an automated, virtual assistant that could have a camera feed, that could take, pictures as inputs, to be able to tell you about mineral composition or expert analysis of other types of wavelengths as well. These are things that people are building, right? I mean, people want to build these things. This is fascinating stuff with these models.
And is that a disclosure of somebody's IP? Like, can I Google for somebody that's already got that out there? Is there a marketplace for spacesuit tech at this point?
I don't know. I don't know. I'm not a lawyer. We just we talk to a lot of customers wanting to do a lot of cool stuff, and that's honestly one of the best parts of my job. Whether it's designing bits of spacecraft as well, that's another use case that people have. But really, there's a lot of different applications that are possible. Yeah, that's really the end of my slide deck. But there's a ton of different applications that we see and that we talk to people about, and how to apply it to space. Now, are you going to take a generative AI model all the way up to space? Not right now, because again, back to the conversation about size, weight, and power. The computational demands for some of these generative AI models is large. You need large graphics cards to do that. But what many of people do is the remote inference method. So you might have your model actually hosted in the cloud, and then have a remote way to send it data and get responses without necessarily having to drag all your computational hardware into orbit. Again, that's a latency decision, because as we know, speed of light starts to constrain things really a lot in space. But I could see a future where the hardware gets better, the models get smaller, they get more power efficient. There's more computational power available. Eventually, we'll probably take the full models up there and start to do stuff. We're already taking smaller machine learning models, so I don't see why these behemoths that we've built now with Claude and Mistral and Llama and others, why we wouldn't take those. But power demands are pretty high right now.
But I think your point's a good one, and I tried to say that earlier with like the olive tool chain stuff is like doing it on the client, which is to say like on the edge or at the edge. Like the edge is actually before the client. The edge is the thing. It's like the last mile, and there's the client itself, and you can do things on the client itself. The edge is still on the network, I think. If anybody has a correction, that's my understanding of it. But but like with like more on premises or on device capability, you can do more locally, and you have neural
Yeah,
processing, etc. locally, doing whatever you're doing locally, in the event that you can't communicate back to the cloud or to call home,
right.
etc. But those kinds of hybrid systems that can do a lot locally, and you
Yeah,
think of it as like a OneDrive or that kind of thing, where it's like it can work locally, and then when you connect it to the cloud, it does the rest of the stuff kind of online, offline, depending on connectivity and other attributes of the client at the time, like how am I doing on power? How am I doing on should I
yeah.
do it locally now or not? Like those feel like solved problems, honestly.
I agree. I think what you'll start to see is more model diversity in terms of size. So some of the newer models or the new teams that are building models come out with different model sizes depending on what they want to do, right? So you might have like a 2 billion size model, and then all the way up to like a 70 or a 350 billion model. That 2 billion model might be perfect for edge deployment locally, right? Just running on more constrained hardware for certain tasks. And then if that's not enough, or if that's too slow, you could actually see a reality whereby you would route a call, back to, I don't know, a cloud provider that has more computational hardware available to actually get a bigger, more expansive answer back. And you get this like, multi-tier model of, hey, how much complexity do you actually need at the edge in space? Can you run this locally? Cool. We don't need a network call. Okay, well, maybe now we do need a network call because your answer is really complicated and I need to think about this. So I absolutely think that as models are used differently and in different scenarios for different power requirements and different computational requirements, you'll see that kind of local first and then jump to remote.
Cool. Hey, just running through some questions in the
Yeah,
chat here. I'll start with the topmost one we haven't yet covered. So there's some talk on Bedrock, and I think people are just wondering if you guys are using Bedrock, or maybe you give us an example of
oh yeah,
how Bedrock fits.
yeah. Bedrock, we absolutely, so the AWS Aerospace and Satellite team using Bedrock, yes, 100%, right? We have customers using Bedrock as well. Bedrock's awesome, right? I really like Bedrock because it's a high level service that gives you API access to an array of models, different sizes, different different capabilities. But the point is, you can choose, right? You can actually choose your capability. You can choose and to match your capability to the price as well, which is really important. We didn't really talk too much about that, but for example, last year I wrote or I co-wrote. It was one of my colleagues, Nareda, that actually wrote most of it, and she's amazing. She actually wrote the vast majority of the workshop at reInvent. But at reInvent, we had a Gen AI workshop that used Bedrock to call APIs using natural language. And the API that we called was actually NASA's imagery picture of the day API. So the workshop, just to sort of summarize it, took a text input and said, today is whatever today's date is. Get me the latest picture from the NASA imagery archive. Okay. And it took that prompt of natural language and actually created an API call with JSON and all of the things that the API documentation actually told the model to build. It then built this URL call, pulled the image back, right? Gave the image and then a description of the image that it had sort of looked at, which to my mind back then, I mean, this is last year, like we're a little further ahead than that now, but this was incredible, right? You can actually ask an API in natural language to pull back data. It gets the data, it validates it all, pulls it all back, and it takes like, half a second. And we built that all on Bedrock. And that was, we had like 200 people, I think, or 150 in this massive hall in Vegas in the Venetian, right? All using and going through this workshop and doing all these examples at reInvent. And we got a really good score for it. Everyone was super happy. Good introduction to Gen AI. I think we used the Claude model, which was at that time Claude 2. It's now Claude 3, and there's other Claudes. But Bedrock gave us that example. So like we absolutely use it ourselves. We use it for reInvent workshops. We use it for demos and workshops and demo days. And our customers use it, right? Our customers like Bedrock because it enables them to just think about API calls. They don't need to think about training models and servicing GPUs and doing all these other things, right? They just make an API call and it's done. So it's a cool service for sure. And it comes with a lot of safety controls now as well. Guardrails about, you can't inject certain terms into the prompts and all of these things. These are configurable by you so that you can actually set up security for Gen AI, which is a hot topic. If you're building a public interface, so for example, if you were building a state and local government type interface, right, and you wanted to use Gen AI, the guardrails are an excellent way to sort of guard against people sending in, malicious or derogatory prompts or whatever they might want to send in to upset people. But that it's a good service.
Next question from Chow is, how would one use AWS IoT services to manage and monitor a constellation of small satellites?
Yeah. So that's a really good question, actually. So our IoT service, for those of you that don't know, uses MQTT and WebSockets over TCP to communicate with devices in the field, right? So it can handle an enormous amount of small devices, and is provided that you can have network access to the endpoints in AWS for that service, for the IoT service, whether that's privately, right, through Direct Connect or an IPsec type of a tunnel, or publicly using our public APIs. You can let these devices communicate in the cloud to build what we call a digital twin. And the digital twin is really a digital representation of that device in the cloud and all of the attributes that you want to model. So again, we actually did this. So the ISS, right, the International Space Station, has a publicly available API. And you can stream, you get access to the API streams and all of the data. You can get like voltages on the solar panels. You can get all kinds of stuff. We did another workshop, the AWS ANS team, where we built out a digital twin of the ISS. And we had like the power fluctuations, how it moved, the real-time cameras, all of these things backed into AWS. When it comes to doing lots of things at once, we have IoT fleet management. We also have something called IoT Sitewise, which enables you to ingest huge amounts of time series data. Again, I don't want this to be a sales thing, right? But we do have a lot of stuff in this space. And since you asked the question, there's a lot of services that are really good at this, especially for very small devices. We can go down to like real-time operating system level for like free RTOS, which is a real-time operating system that runs on very small chips, and back that into the cloud. So there's loads of options there if you're managing a fleet of satellites.
That's really cool. Thank you. I'm just going to rattle through anything else that's outstanding here. Yeah. I think we're good on the questions, so it's just kind of open at this point. Let's plan to go for another 23 minutes unless we get tired and want to call it. So just open forum if you want to, I guess, like I'll ask for people to raise their hand if you don't mind. Type it into the chat, that's fine too, but raise your hand and I'll call on you. Yeah, absolutely. Happy to field anything about AWS, about space, about my team, about what I do, about what I think about things within reason, to do with space, of course. Go for it, Tim.
Thank you. Alistair, where can we find these AWS ANS workshops to attend in the future? Yeah, great question. They're usually done, we usually do them at our public sector summits, which was recently in DC in the US. And we are going to do several at reInvent as well, which is in Vegas this year.
the weekend after Thanksgiving. So I can't remember the exact dates, like the 4th of December or something like that. I'll be there. And we do these workshops for customers. We can do them sort of one-on-one as well. So if you are, speak to your AWS account reps, and we can tee up, a hackathon or doing, these workshops or whatever you want to do to educate you about space technology and different types of methods of data ingestion, data manipulation, generative AI, like all of these things we can do using the account team is probably your best bet. But if you come along to one of these events like reInvent, then you can sign up and you can come along to the workshop and you can just do the workshops as part of reInvent. So it's a really, really great way to do it because everyone's super focused. You've got access usually to the people that wrote the workshops there and then in the room, and everyone's super excited to get engaged and do all these things. So workshops are a big part of the solution architecture job, and we love to do them. We love to build them and do them.
Thank you.
Alistair, just another question I'm thinking about, like I'm noticing that your team is called Aerospace and Satellite.
Mm-hmm.
So aerospace being maybe a traditional industry, if you will, or a long-standing one, and satellite, of course, been around a long time, but not all new space, like many satellites and whatnot that we're talking about. And space, like Elon stuff. What's his called? Starlink.
Starlink is a product. Yeah.
Yeah, but I guess my question is like, is this just kind of like a patch of accounts for Amazon, and like this is like an industry team, just like your neighbor is somebody that's covering finance, for example? Is that kind of how this is organized in Amazon?
It's a business unit for sure, and it's a global unit, right? And we have people in EMEA, in America, and out in APAC as well. So we tend to be global. So we're located all over the world. And we have a very well-defined structure for, in that we have lots of account managers that help customers and businesses. We cater for everything from startups, right? I want to launch something into space to, as you say, very well-established space customers as well. So we really run the whole gamut, honestly. And it's a very, as I say, well-defined business unit within AWS.
Yeah.
And we have a public page if you want to go there,
Okay.
that I can get.
Okay. Yeah, no pressure or anything. I mean, we could go look at that. But yeah, no, I think like there's no shame at all here in plugging anything Amazon related and just your guys' overall capabilities. I mean, this is totally open, just open to anything you want to say about the company and what is.
Yeah. I love my job. I love my customers. I love speaking on things like this. It's a lot of fun, frankly. And if I get a little bit too excited about some of our capabilities, then please forgive me.
But here's a new question from Chow. What are the benefits of using AWS for aerospace data analytics compared to traditional on-premises solutions? I guess you could say like a Tableau or something.
Well, and Tableau is a great AWS partner, actually, and we work with lots of customers that actually run Tableau in the cloud, and have access to Tableau cloud offerings. Data analytics in the cloud is great because of the amount of storage that you can access in different manners. So you can have like very low cost tiered storage. You can have hot storage where you need extreme performance. You just get access to loads more options, and it's usually pay as you go. So you're only charged for what you use. You don't have to do, large sort of, plan for the next 5 years or whatever. You can just sort of grow on AWS, and solution architecture is solution architects, or like I used to be, and are really, really keen to help you optimize that and make sure that you don't, do the wrong things or spend too much money, or, have a bad time. We want you to use the right tools for the job. So by accessing and analyzing data at scale, by giving you access to the latest and greatest hardware, I think it's much better to do data analysis on-prem. It can be a very compelling economic argument. It can also be a very compelling security and compliance argument as well, because many of our customers need very stringent compliance regimes and compliance requirements. So NIST 853, CMMC 2.0, these are like compliance regimes that are incredibly difficult to hit on your own. By doing things in AWS, we sort of guarantee this shared responsibility model where, we secure security of the cloud, and you secure everything that's in the cloud, or your data in the cloud. So, it's arguably easier to hit these and security and compliance regimes by using cloud. And also, when I used to work in the state and local government team, I used to work again with actually HSS customers in New York City, funnily enough. And we, they want to test out some hardware, right? They want to test out an FPGA for doing genome sequencing, right? And they're like, yeah, we could get one ourselves, and it would take a while, and months and procurement and blah blah blah. Or you could just spin one up in AWS, try it, you pay for it as you use it, and then shut it back down. And you could run your entire, like, do we need this hardware question in a matter of hours for the cost of, a couple of drinks. So it's a really good environment to do experimentation, and lowering that barrier to access to different hardware is really important.
Yeah, there's a lot to be said there. That's just my personal experience with that topic. Like Tableau kind of started as an on-premises solution, for example. I know we've already said here that I guess the way that I think about it is like analysis, data, in the topic of data analytics, right? Like analytics and analysis implies almost a proprietary secret thing, right? You're looking at data and you're trying to have insights and make business decisions and come up with strategy and everything. So
Yeah.
if you're doing that in an environment that's not very private, and it's not within your firewall, and it's not under all the controls and stuff, and you're just trusting any old cloud provider, and you're not in, high GCC high and all the things, like, you better be careful depending on what data you're looking at and what there's a variety of reasons you need to be careful with that.
Sure. I mean, like any tool, I think, if you don't configure it properly, then, you're going to have a bad day. But with AWS, there's a lot of ways to do that correctly. And there's a lot of customers, more importantly, doing that correctly today in very difficult compliance environments, everywhere from, FedRAMP compatible environments up to some higher classifications as well. But we're here to help you through that, right? And we're here to help you secure things properly, to limit access, to build things the way that what we call well architected. And we do free well architected assessments of any cloud workload that you want us to do. And we can tell you, hey, look, you might want to look at this. It's the password entry thing isn't up to spec or whatever. So like all of these things are solvable problems. I think more security is never a bad thing. So you should always just follow best practices and make sensible choices.
Cool. Any other questions that are burning for people, or any further comments on the discussion or stuff people like to add? Going once. Oh, we got Tim. Oh, go ahead. Go, Tim. You got it.
I got kind of a random one that's been in the back of my mind.
Sure.
Alistair, you mentioned space is just flat hard across the spectrum. I've shot the breeze with my brother about this a bit, and we talked about how manufacturing might be an advantage in space due to the lower gravity. Is there any truth to that, or are we just full of it?
I'm not a space manufacturing expert, unfortunately. I can see definitely certain things being easier, but again, you need to weigh that up against the cost and difficulty of getting things into space in the first place, right? Why are you building things in space? Why are you doing it that way? Why are these things happening? I think you need to answer those questions before you can sort of say, yep, this is the environment for me, right? You know, this is easier to do in space. I think that problem is very, very wide ranging. And I think it encompasses a lot of different disciplines, technologies, psychologies, lots of different things. But yeah, I mean, building things in space is what I think is going to be the future, especially when it comes to building habitats or even rockets and spacecraft. Eventually, I think we'll build in space, and yeah, I think it's an exciting time to get engaged with the industry for sure. There's a lot of innovation happening right now, and there's a lot of interest in commercial backing in different companies.
Yeah, that's pretty fascinating. If you think about, God, I mean, gravity, what an impediment.
Yeah, well,
Come on, why can't we be floating?
yeah, that's right. But again, getting up there, getting the hardware up there, not easy. Until we maybe build a space elevator or something like that, I think that would be really cool.
As long as there's a buyer, it's a good idea.
That's right. That's right.
Tim says I think a lunar base will be a major launch pad for
Yeah,
space progress in general. Once
I agree.
set up, yeah.
I agree. I think having the moon as a launching space. I think there's the quote. You know, if you can get to the moon, you're halfway to anywhere. Because of the way the rocket equation works, right? You have to expend so much delta V to actually get there in the first place. But once you're there, getting anywhere else in the solar system is really quite easy. So if you could build manufacturing systems on the moon for rockets and, you know, habitats as a launching pad, that would be really exciting because you could mine lunar regolith, you could, you know, use helium-3 on the moon for power, for fusion. You could really open up the whole solar system that way. And it's, yeah, I think that's far in the future, but I'm a sci-fi nerd, so I like to dream a bit.
Might as well
Yeah,
start working on it now.
Yeah, yeah, that's right. That's right.
Any other questions or comments?
Eric, are you going to go into that next piece where we're talking about next month? And
oh yeah, let's do that. Thank you
up?
for the reminder.
Yeah.
So I've reached out to a few people kind of in my neck of the woods, which is like northwest Washington, like last couple counties before Canada. And I probably have a lead or two, but not a lot of depth. So if anybody's kind of like got a friend that's got a topic and is dying to talk about the moon base or whatever, let me know. Anybody have a lead or a company or a person in their network that, like, again, would be a good candidate to give a talk similar to what Alistair's doing? Again, just sharing on what they know about and just open discussion for us to learn more about the broader topic here.
I've got a couple in mind that I can't promise, so I'll get back to you on that.
No problem. Yeah, ping me if you don't mind, Tim. I know we're connected. I appreciate that.
Yeah, for sure. I'll keep my eyes and ears open as well, Eric. But
yeah, we'll come up with something, I'm sure.
Yeah, definitely. Yeah, I'm sure Mike Doyle, you know, the big boss, has it on his radar as well. But coming up in October is NASA's Space Apps Challenge.
Mm-hmm.
So that would be good to at least touch on next month and prime some folks to get interested and do a shameless plug for it as well. October 5th and 6th. It's a worldwide event, but if you want to be in person, the closest base to Northwest here is in Seattle. So it's a great couple days where geniuses, space nerds get together and hack away and create some projects that are going to be put in front of actual like NASA folks to judge. And It's a really, really good event, and it's a good hackathon. And Al, I'm pretty sure there's going to be some AWS folks there, because I know last year there was, for sure.
Oh, nice. Yeah, feel free to add me on LinkedIn if I can help out, or if I know some people or whatever, then yeah, I can definitely tell them. That's awesome.
Absolutely. Yeah, and I put the link as well in the chat, spaceappschallenge.org. Check it out, everybody.
Excellent. Thank you so much.
Okay, well, it sounds like we're coming to the end here, but hey, Alistair, thanks again. That was awesome.
Very welcome. Yeah, my pleasure.
Thanks to Tim and others for participating tonight. That always helps it be great. So thanks for showing up, and great to meet everybody. Have a good night, and we'll see you in a month. Thanks a lot. Bye-bye.
Take care, everybody. Thanks again.
Thank you very much, Alistair.
Anytime. Bye now.